All right, ladies and gentlemen, we're going to take a look today at graphing piecewise functions. So hopefully you still recognize what we have here. We've got our boundary, our break, our wall, whatever we want to call that, at -1. And so if x is less than -1, then we're going to use the function the opposite of x plus 1. If x is greater than or equal to -1, then we're going to use the function 2 times x plus 1. So we're going to start these in a little bit differently than we have in the past, and I think you guys should be pretty successful because we did a good job substituting and evaluating the functions. But the first thing we want to do is we want to put in a dash line or a break at x equals -1. So we want to put in a break line there. And then what we're going to do is we're going to write our function on the appropriate set. Alright, so for x is less than -1, that's to the left. We're going to graph the function opposite of x plus 1. For x greater than or equal to -1, we're going to graph the function 2x plus 1. But we're going to do things a little bit differently than we have. What I'm going to have you do is evaluate those functions for given points. But if you notice, there's no given points yet. And so what you're going to do is you're going to pick those points. So for our red function, as I call it, the less than, we're going to pick x values that are less than -1. Now we're always going to start with this breakpoint. We want to graph that, and I'll show you guys what that looks like. And then I want to pick 2 or 3 more points that are less than -1. So I'm just going to pick -2, -3, and -4 points to the left. And then we're going to take the opposite of x plus 1. Now you can do this by hand or you can do it on the calculator. But we're going to have our x and our y. So we're going to have points that we can plot. If I take the opposite of x, that becomes a +1 plus 1, which would be 2. If I take the opposite of -2, that becomes +2 plus 1, which is 3. And then the opposite of -3 is 3 plus 1 is 4. And then we can see the lovely pattern here. And then what you're going to do is you're going to plot those points. We're going to plot the point -1, 2. So we go to -1, we go up to 2. Because I'm not equal to -1, this one has the open circle. So it's back to like open and closed circles for those. But now I can plot -2, 3. So I go -2, +3. I plot -3, 4, and -4, 5. We're going to connect those to make a line. My line's getting a little bit off there. So I didn't use a straight edge. But that's what it's going to look like. Now I'm going to take my blue function, the values that are greater than -1, and I'm going to have 2x plus 1 and y. So I'm going to start with -1. Each function is going to start and evaluate -1. The difference is one of them is going to be an open circle when you're just less than or greater than, and the other one's going to be a closed circle when you're greater than or equal to or less than or equal to. But now I need to pick values that are greater than -1. So 0, 1, and 2. So if you're looking, you're just basically starting here, counting to the right. You're starting at -1 and counting to the left for each of those functions. And like I said, we can do this on the calculator. So we could go to our graphing calculator, and we can type in, and Miss Woodard could remember the function for a little bit longer than that, 2x plus 1. So we're going to type in y equals 2x plus 1. We're going to check our table set and see what it's on. It's on auto, but it's starting at 14. We've already we've already picked the x values we want, so we're going to have it start at -1. It's going to go up by 1. So that's our delta table. And so then we're going to do second table. And so now we have our values of -1, 1, 3, and 5. So that's the other way we can do that, either with mental math or with our table of values. We have negative 1, 1, 3, and 5. And so we're going to go and graph those points. So we have negative 1, and that's a closed circle. We have 0, 1. We have 1, 3. And we have 2, 5. And we're going to connect those. But notice, ladies and gentlemen, they're two completely different graphs. The red doesn't cross over. Remember, we talked about this being like the Berlin Wall. The red line can't go past that because I can only use my red function for values that are less than negative 1. My blue does not go to the left because I can only use my blue for values that are greater than or equal to negative 1. And so you're going to end up with these kind of jostly looking graphs that don't always match up. They sometimes make a V like we have here. Other times they will look like they make a straight line, continuous, either positive or negative slope with those. It just depends on the function that we have, all right? But I think it's going to be best if we go back and use this idea of we can evaluate these functions for given values that are less than negative 1 and values that are greater than negative 1, all right? So if we take a look, you guys have it on your own. So I'm going to ask the sub to pause the video now, or a student to come up and pause. So we'll give you guys a little bit of time. I want you guys to try with your partner to follow those steps. So I want you to draw in the line at 0, write the correct function on the left and the right hand side of 0, and then go through and make your table of values. All right. So hopefully someone's paused the video by now, because I'm going to get started making the answer key. All right, so we have to have our break line at 0. So it's right here on the y-axis. For x is less than 0, we're using this function, so less than is to the left. So x plus 2 is over here on the left. For x is greater than 0, we're just using x, so we have x over here. I'm going to make my table of values. And for some of these, it is just easier to do this by hand. So I've got x plus 2. We're going to always start with 0, and then I have to go to the left. So I'm looking at negative 1, negative 2, negative 3. So negative 1, negative 2, negative 3 for that. So 0 plus 2 is just 2. Negative 1 plus 2 is 1. Negative 2 plus 2 is 0. And negative 3 plus 1 is negative 1. So now we're going to graph those. So I'm going to graph the point 0, 2, but I need to look at it a little bit more closely. This is just less than 0. I'm not equal to 0, so this is where you have to have your open circle at. So 0, 2 is an open circle. Then I have the point negative 1, 1, the point 2, 0, and the point negative 3, negative 1, and then I connect those to graph my function x plus 2 if x is less than 0. So if we look, all of these x values are less than 0, so that's why my red graph is on that left-hand side. I'm going to take a look at my next function. Always start with 0, or whatever your break there is, and then pick 2 or 3 points to the right of it, because now we want to be greater than or equal to 0. So 1, 2, and 3. Your function is just x, so when you plug 0 in, you get 0. When you plug 1 in, you get 1. Pretty easy. That's why I said it's sometimes easier to do this by hand and not on the calculator. But what you're going to end up doing is graphing the point 0, 0. You're equal to 0, greater than or equal to 0, so our blue function is the one where we can have the closed circle, and then we have 1, 1. 2, 2, 3, 3, connect those, and there is our function. All right, so once again, this is an example where you don't create the V, but you have kind of like the jump in your line, okay? We have one more type of function to look at, and that's our step functions here. Step functions, if you notice, there's no x. It's f of x is 0 between negative 3 and negative 1. It's 1 between negative 1 and 1. It's 3 between 1 and 3, and then 4 between 3 and 5. So these are all going to be, for these step functions, horizontal lines. All right? So what I usually do is I go back and I look at this and I kind of put in those breaks. So I'm going to have one line, one step from -3 to -1. We call those asymptotes. Then from -1 to 1, we have another step. From 1 to 3. And so you notice there's no gaps in our steps, so it's continuous. And then from 3 to 5. So now I'm going to take a look at what I need to graph. I'm going to graph 0 from -3 to 1. But x is going to be greater than or equal to -3. So at -3, I have this closed circle. I have this horizontal line at 0. But at the -1, I'm just less than. I'm not equal to it. So I have this open circle there. Now if we take the next one, I'm going to be 1 from -1 to 1, but I can be greater than or equal to -1. So I'm going to have 1, closed circle at the -1, step, and then open circle at 1. I'm going to be 3 between 1 and 3, but I can be greater than or equal to 1, so I'm going to have the closed circle at 3, at the and going over, and then open circle. So I close circle from 1, open circle at 3, and the horizontal line at 3. And then last but not least, I have a horizontal line of 4 between 3 and 5. So close circle at the point 3, 4, horizontal line, and then open circle at the 5. So this is what we mean by our step functions. All right. You have a book assignment. Your book assignment, you will need graph paper, and I made copies of the good graph paper that the sub can hand out to you guys. But your assignment is on the agenda from yesterday. So it's page 117, numbers 21 through 27.